A set is any group or collection of objects, people, or places. Examples of sets are the following. We have a set of books, set of fruits, and a set of kitchen utensils. Remember, a set is well defined if the elements or the members are clearly identified. The elements or the members must be distinct, unquestionable, and exact. And the elements are what we call the member of the given set. We have three methods of describing a set. The first one is what we call roster notation or the listing method. The second one is the verbal description method. And the set builder notation method. Roster notation or what we call listing method is a method describing a set by listing each element of the set inside the braces. Remember, each distinct element is listed once and the order of the elements does not matter. So example of a set written in roster notation or listing method are the following. Set A has the elements 3, 5, 7. Set B has the following elements: January, June, July. The second method is what we call verbal description or verbal descriptive method. It is a method of describing a set in words. For example, set A is a set of leafy vegetables. Set B is a set of primary colors. So instead of listing down the elements of a set, we describe the elements or the members of it. Finally, we have set builder notation. It is a method that lists the rules that determine whether an object is an element of the set rather than the actual elements. So we are going to state a rule for the elements of the set. For example, set A is a set of all x's such that x is a day in a week. So instead of writing Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, we just set a rule for those elements. Set M is a set of days in a week that starts with D. This set is written using verbal description method. Set M is a set of all x's such that x is a day in a week that starts with D. While this set is written using set builder notation method. Finally, set M has the following elements: Tuesday and Thursday. This set is written using the roster or the listing method. Let's talk about the cardinality of sets. The cardinality of a set is the number of elements in the given set. Let's have the following examples. First, set A has the following elements: Saturday and Sunday. So how many elements do we have here in this set? We have 1 and then 2. Meaning to say, the cardinality of set A is 2. Next, set B is a set of months of the year with 31 days. So before we can determine the cardinality of it, we must list all the months of the year that has 31 days. So let's begin with January, followed by March. Then we have May, followed by July, August, then we have October, and finally we have December. So how many elements do we have in all? We have 1, 2, 3, 4, 5, 6, and 7. Meaning to say, the cardinality of set B is 7. Finally, set C is a set of all x's such that x is a multiple of 3 less than 14. So let's write down all the elements of this set. So let's list the multiples of 3 less than 14. So we have 3, 6, 9, and 12. We cannot include 15 because the rule states that it must be a multiple of 3 below 14. So we have 1, 2, 3, 4 elements, which means the cardinality of set C is 4. Now let's have what we call subset. So let's consider the following sets. A has the elements of 1, 3, 5, 7, and 9, while B has the following elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or the counting numbers from 1 to 10. By inspection, you can see is an element of A, and also 3 is an element of B. Similarly, 9 is an element of A and B. You will also observe that every element in set A is also contained in set B. Meaning to say, 1, 3, 5, 7, and 9 can be found in set B. When a set is contained in another set like set B, therefore you can say that set A is a subset of B. How about universal set? A universal set is a set which contains all the elements of other sets. It is usually denoted by this symbol. In this example, the universal set contains the following elements: 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, or the even numbers from 2 to 20. It has the following subsets: A, which has the elements 14, 8, 12, 16, and 20. All the elements of set A can be found in the universal set. Set B has the following elements: 10 and 20. 10 and 20 can be found also in the universal set. Set C has the following elements: 2, 6, 8, 12, 14, and 18 that can be found again in the universal set. Meaning to say, set A, set B, and set C are all subsets of the universal set. How do we determine how many subsets does the given set has? So we're going to use the formula 2 to the n power, where n is the number of elements in the given set. Let's have this example. Set P is a set of all x's such that x is a month of the year that start with J. So what are the elements of P? We have January. Of course, we have June and July. So what is the cardinality of set P? We have 1, 2, 3 elements. Meaning to say, using this formula, we're going to have 2 to the n power, where n is the cardinality and the cardinality of the given set is 3. So we're going to substitute 3 in the exponent. So we are going to have 2 cubed, which means 2 times 2 times another 2, which is equal to 8. So, set P has 8 subsets. So, let's start listing down all its subsets. So, we're going to begin with one element at a time. Let's have January. Always remember to enclose each subset with braces. So we have January, June, and July. After having one element, let's have combination of two elements. So we're going to start with January and June, followed by January and July. And of course, don't forget the combination of the months of June and July. So we're done with the combination of two elements. Let's proceed with three elements. So we have January, June, and of course, July. You can notice that this subset is the same as the original set. It is because that there is a rule that all set has a subset which is equal to the given set itself. And there is another rule that implies that all subset has a subset which is an empty set, or what we call null set. Again, let's go back to the given. Set P should contain 8 subsets. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 subsets already.